Here we're going to be working on a Nintendo Switch Lite that was mailed in for no power. I already took the motherboard out. When we plug this into the charger, nothing happens. I plugged an amp meter and the amp meter just shuts off. It doesn't even show if it's being charged or not. So there's some type of short circuit on the board, and that's what causes the meter to go blank and not to display anything. I've done this in previous videos where I showed you how the meter goes off when you plug the charging cable onto the motherboard, and that's because a short is happening on the board. Now, customer said it doesn't power on, it doesn't charge. I took the back cover just to see if it has any loose wire or water, but didn't notice any. I didn't want to remove anything else because I don't want to do any more damage. Based on what I'm reading here, the customer took the back cover just to see if there's any liquid damage or anything loose, but he did not attempt any repair. You can't always believe what you read. You cannot always believe what you read. Here's what I found. Now, the customer may not be aware of this. He may have bought this game console refurbished, or maybe he bought it used. We do not know how the customer came about having this Nintendo Switch. Look at the attempted repair on the USB-C port. Look at solder on those pads here, and flux. And all the customer did was take the back cover just to see if there's anything loose. No repairs whatsoever. I do not know if the USB-C port is soldered on properly. We do not know if the pins, the hidden pins on the bottom, are making a good connection or not. We do not know if we have missing pads under the USB-C connector. Now all I can do is just push on the front pins to see if there's anything loose, and that's about it. I cannot see what's going on under the connector. We have pins under here that cannot be seen. So assuming the charging port is soldered on properly, let's just assume it's soldered on properly. Now the meter is shutting off because there's some type of short on the board. And a USB-C charging port, it's unlikely to cause a short. So let's look elsewhere. I do see a discolored component here. We have a discolored component here too. Now that may not mean anything, but it's just what I'm noticing by doing physical inspection. I have to keep that in mind. So let's see. And we have a short here. Look at this. Now, a short on this area of the board could be due to one of the capacitors, possibly this one here, but from experience, I know that these capacitors rarely short out on this console. So I'm going to start by removing the chip, just take an educational guess, remove the chip and see if we still have a short. And we'll take it from there. If we do not have a short, then we'll just put the chip back and no harm done. Okay, that's it. Let's put the chip on the side. Wait until the board cools down a bit and test to see if we have a short. If the board is super hot, you may get a reading that shows a short because of the excessive heat on the board. So just wait until the board cools down a bit. And do not immediately try to cool the board by applying alcohol onto it. It's extremely hot right now. It's not good to go from extreme hot to cold. 20 seconds of patience goes a long way. Let's try to measure now. Okay, so we still have a short. Now the other thing I want to do is desolder this cap here. It looks discolored, so there's a chance that this cap may be causing the short. And if that's the case, this will be the first time a short happened on a Nintendo Switch because of a cap. And why not just move this too? The short is gone on this cap. But we still have a short on this cap here. Let's see if we still have a short. No short here. We do not have a short here. But we have a short on this cap here. Where is this cap leading to? Okay, what I'm going to do is solder the chip back. We may have to inspect this under a thermal cam just to see where the short is coming from, but before I do so, I have to solder the chip back. And before I solder the chip back, we need to prep the board. Big Boss is trying out the board just to see if there is any signs of life after we separated the capacitor. He plugged the battery onto the board and he's gonna plug the charging cable and we'll see. ولا شيء. Okay, same. Before, when we plug the charging cable, the ammeter would show black. Nothing comes on the meter because of a short. We still have a short, but we have the capacitor disconnected. I just want to see if there's any signs of life after we did what we did. Meter comes on, but the charging rate is 0.09 amps. Not good. 5 volts at 0.09 amps being drawn by the motherboard, that's not good. The next step would be to inspect it under the thermal cam. Anything hot on the board? Possibly from the side of the board, but not from the top side of the board. Maybe from the bottom side. Yeah, look at that. Look at that. Which chip is that? Okay, so this is the chip that's next to the one that we just worked on. I knew it. I knew it. I knew it would either be the chip that's next to the one that we worked on or the USB-C port. Let me unplug everything and let's go back under the microscope. Right now, all the work that we are doing, we are assuming that the USB-C port is good. The thermal cam shows that heat is coming from this chip, a lot of heat. Both of them are power ICs, charging ICs. If we test in resistance mode, we get 0.91 ohm. So that's it that short. So it's very likely that the chip is damaged. This one here. Let's go ahead and replace it and see if that will fix our problem. And pin number 1 is on the bottom right. And the job is done. Just quick cleanup. That's it. Now we're gonna test to see if we still have a short on those caps. And look at this, the short is gone. The short is gone. Resistance mode. I mean, of course, if diode mode is not showing a short, then resistance mode is gonna have a reading 135 kilo ohms. Okay. Okay, so let's plug the battery in and see.
Just delivering good news, man.
What is it?
Well, now if I open it, I can tell you.
Okay.
I don't know.
So the ammeter is reading 0 amps being drawn, but it's reading 15 volts now instead of 5. Let me take a look at the thermal cam quick. I do not know if the battery on this console is good or not, and I do not have one to test with. I do have the Nintendo Switch battery, but not the one for the Lite. The Lite is a different connector. Right now, the next thing I'm gonna do is I'm gonna go ahead and replace this IC as well. Because I'm running out of options. I'm running out of options. Okay, we're all good. Now we're gonna test and see. Today we're continuing to work on this Nintendo Switch Lite motherboard. Last time I worked on it and I was not able to figure out the problem. Since you're watching the video, you know what was done and what wasn't done to that board. So we still have a short here. Now there's a symbol here for a diode. What I'm going to do is remove the diode and see if that's possibly what's causing the short. Because there's nothing else I can think of that could be causing the problem. We do not have any board diagrams for the Nintendo Switch. We do not have any circuit diagrams, so we have to figure this out. Okay, so let's remove it on the side. Just want to see if that will release the short. Meter in diode mode. And look at that, the short is gone. The short is gone. So the diode is what's causing the problem. Wow. I never had to change a diode on a Nintendo Switch before. I do not have a donor board for the Nintendo Switch Lite, but I do have a donor board for the regular Nintendo Switch. I do not know if we can find the same diode on the board here. We have to have one on this board somewhere. Right there, right there. We have two. So we have one here and we have one here. Let's go with this one. I do not know the values of those diodes, but I'm gonna assume that this will work. Is it the same one? And it's not. It's not the same one. Okay. So let me put this one back in case we have a use for it in the future. We need a bigger one. Okay, so nothing on this side of the board. Let's flip the board. I think this one is too big. It's too big. So what do we do? So the board is a no fix as of now because we need to figure out the value of the diode. I was not able to locate a donor diode from the donor board. Let me go back to that diode. Maybe we can read what it says on it. Yeah, it looks like an 8C. I'm gonna look it up today and see if we can figure out what this diode is or the value of this diode. Okay, no short here and no short here. Diode is what's causing the short. Right now I'm not able to get any Nintendo Switch Lite boards for donor ports from anywhere, and all we have to do is find out the value of this diode. If there's anybody that knows, just leave it down in the comments. That's it. I hope you enjoyed the video. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.